Good morning, everybody. So today's topic is quantum number. So let's see about quantum number.
Quantum numbers. In this module, you will learn about the four types of quantum numbers, their definitions, the rule for determining their values, and their significance. Quantum mechanics proposes that moving particles exhibit wave-particle duality. Erwin Schrödinger gave wave equation as operator H psi equals to E psi, where H is a Hamiltonian operator. The wave equation explains the dual nature of matter as a particle and as a wave. The wave function psi simply represents the amplitude of electron wave. However, psi square gives the region in space around the nucleus where the probability of finding an electron in an atom is the maximum. This three-dimensional region is known as orbital. The solutions to the Schrödinger wave equation yielded the quantum numbers. Quantum numbers describe the energy possessed by an electron, its orientation, and the three-dimensional shape of the region in space occupied by it. There are four quantum numbers.
So in this way, there are four quantum numbers. So let's see all four types of quantum numbers.
N, the principal quantum number. L, the azimuthal quantum number. M, the magnetic quantum number. And S, the spin quantum number. Let's look at the principal quantum number N. It was the first quantum number to be discovered by Niels Bohr in the year 1913. The principal quantum number represents the energy level or shell in which the electron is present. N can have the values 1, 2, 3, 4, and so on, where 1 corresponds to energy shell K, 2 corresponds to L, 3 corresponds to M, 4 corresponds to N, and so on. Here, N will always be a whole number and never less than 1. Each energy level has a specific energy which is also determined by the principal quantum number N. The greater the value of N, the greater is the energy possessed by the electron present in the corresponding shell. Principal quantum number also determines the average distance of an electron from the nucleus. The greater the value of N, the greater is the average distance of the electron from the nucleus. It was found that electrons present in the same shell may possess different energy and hence different angular momentum. Thus, within the same energy shell, there must be number of subshells or sub-energy level. On the basis of this, Arnold Sommerfeld discovered the second quantum number called azimuthal or angular momentum quantum number, denoted as L. The value of L determines the subshell in which the electron is present. However, the number of subshells that are present in a shell depends on the value of N. The value of L varies from 0 to N minus 1. If N is equal to 1, then L is equal to 0. If N is equal to 2, then L is equal to 0 and 1. If N is equal to 3, then L is equal to 0, 1, and 2. And if N is equal to 4, then L is equal to 0, 1, 2, and 3. Each value of L represents a particular subshell. L equals to 0 corresponds to S subshell. L equals to 1 corresponds to P subshell, L equals to 2 corresponds to D subshell and L equals to 3 corresponds to F subshell. Thus, K shell has only one subshell, S. L shell has two subshells, S and P. M shell has three subshells, S, P, and D. And N shell has four subshells, S, P, D, and F. Energy of S subshell is lower than the energy of P subshell, which is lower than the energy of D subshell, which in turn is lower than the energy of F subshell. The next quantum number given by Summerfield is the magnetic quantum number M. The magnetic quantum number signifies the number of possible orientations of a subshell in space, thus determines the number of orbitals present in any subshell. For any subshell which is defined by a particular value of azimuthal quantum number L, M has values ranging from -L to +L including 0. The total numbers of values M can possess for any value of L is 2L plus 1. So, if L is equal to 0, M can have a single value 0. For L equals to 1, M can have three values, -1, 0, and +1. For L equals to 2, M has five values, -2, -1, 0, +1, and +2. For L equals to 3, M has seven values, -3, -2, -1, 0, +1, +2, and +3. Each value of M represents a particular orbital. This means that each S subshell has only one orbital. P subshell has three orbitals, D subshell has five orbitals, and F subshell has seven orbitals. The shapes of these orbitals are determined by the azimuthal quantum number L. The S orbitals are spherical in shape, the P orbitals are dumbbell-shaped, while the D orbitals are double-shaped. Let us now check out the spin quantum number. The concept of the spin quantum number was first put forth by G. Allen Back and Goldsmith in 1925. This quantum number refers to the spin of an electron and is denoted by S. An electron spins on its axis spin for one electron will be +½ and for the other -½ These two electrons of opposite spins will be present in the same orbital of the S subshell. And -1. Here 0 corresponds to 1, 2.
So in this module, what you have learned? So we have learned the following points. First one, there are four quantum numbers. The first one is the principal quantum number, n, that is denoted by n. And n can be the value 1, 2, 3 and so on. And it signifies the energy and average distance of electron from the nucleus. And the second quantum number is azimuthal quantum number or angular quantum number, and it is denoted by L. And this quantum number describes the motion of electron in orbital around the nucleus. Third thing, I can have L can have value varying from 1 to n minus 1. So here 0 correspond to S or subshell, 1 to P, 1 to p orbital, 2 to d orbital, and 3 for f orbital, and so on. And the third quantum number is the magnetic quantum number, that is denoted by m, and this quantum number determines the magnitude of the magnetic field generated due to motion of an electron. And the value of m range from -1 to 0 to +1, and each value of m represents a particular orbital, and the shape of the orbital is determined by the azimuthal quantum number. So this S subshell has only one orbital, which is spherical in shape. P subshell have 3 orbitals, which are dumbbell shape, and D subshells have 5 orbitals, which are double shaped. And the fourth and last quantum number is the spin quantum number, that is denoted by small s, and this quantum number refers to spin of an electron. For an electron, the value of s is equals to half, either positive or negative. So S signifies the direction of spin of an electron, and also help differentiating two electrons in atom having the same set of quantum number, and these electrons are called an electron pair. Thank you. Have a nice day.